Hello everyone, in this video I'm going to show how to build the decision tree and we will continue HELOC example. In the HELOC example we have two predictor variables age and income and we will compare the Gini indexes of the best splits for the two predictors. The split using age is equal to 49 produces the Gini index of 0.25, using income is equal to 64,500 produces the Gini index of 0.2727. Since the Gini index of the age is the smallest, 0.25 is less than 0.2727, age is used as the root node on the decision tree with a split of 49. Next, we find the probabilities that a customer responds to HELOC offer given the customer's age. In general, this probability is found by finding the proportion of cases in the partition that belongs to the target class. For example, for the partition less than 49, we have two cases that responded to a HELOC offer and total 16 cases. Therefore, 2 over 16, which is equal to 0.125, is the probability for the left branch. And now when the age is greater than or equal to 49, we have 3 cases responded to HELOC offer out of 4. Therefore, the probability of class 1 is 0.75. To grow the decision tree, the process is repeated for all the partitions until no splits can further reduce impurity. In other words, the recursive process terminates when it can no longer produce a lower Gini index or when all the partitions become pure subsets. Recall that pure subsets have a Gini index of 0. And now here in this figure, you see the result of the entire recursive partitioning process. And note that age is split at 23.5 and 49. And income is split at 39.5k, 59k, 102k, and 107k. In this case, all partitions are pure subsets. Within the older age group, 49 years and older, those who earn at least 39.5k in annual income are likely to respond to the HELOC offer. Among the younger age group, individuals who are younger than 23.5 years with an annual income of at least 59k are likely to respond to the offer. Individuals who are between 24 and 49 years old and earn an annual income between 102k and 107k are also likely to respond to the offer. While the classification tree produced in this example is relatively simple due to the fact that we use a small data set with only 20 observations and 2 predictor variables, age and income. A large data set with many predictor variables will likely generate a very complex tree with many levels of decision nodes. And as the number of partitions increases, the misclassification rate from the training data set will decrease eventually to 0. But for a new data set like validation, the misclassification rate first will decrease, but then increase after a certain point due to overfitting. So next I'm going to talk about pruning. Pruning is an important step to optimize the complexity of the final decision tree. So the pruning is the process to reduce the misclassification rate in the validation dataset by replacing a branch of the tree with a leaf node. Here on the screen, you see 5 additionally randomly selected observations from the HELOC dataset. We use this dataset as validation data to prune the fully grown classification tree. And here on the screen, you see a pruned tree where that used to be an interior node with a split point where age is equal to 23.5 is now replaced with a leaf node. Because the majority of cases that reach this node belong to class 0, the leaf node predicts that customers in this subset will not respond to the HELOC offer. So how do we understand that? Look at our validation data set, and if age is less than 49 years old, 23 here and 43, both of them, regardless of their income, do not respond to HELOC offer. Therefore, instead of splitting the left branch furthermore, we replace it with a leaf node. This simpler tree yields the best classification performance on the validation dataset. So let's check it. Here, if age is greater than or equal to 49, which in this case we have 50, 56, and 62, and with an income greater than or equal to 39.5k, in this case we eliminate the first observation, 87 here and 71 here. then they will respond to the HELOC offer. Therefore, this simpler tree correctly identifies all of the cases in the validation dataset. And we have 3 rules that we derive from the optimized tree. If age is less than 49, then the customer will not respond. If age is greater than equal to 49 and income is less than 39.5K annually, then the customer will not respond. If age is greater than equal to 49 and income is greater than equal to 39.5K, then the customer will respond. In the following video, I'm going to show how to use analytic solver to build a decision tree.